Hello and welcome to Ms. Ma's Advanced Functions class. This is 3.4, Transformations of Cubics and Quartics. So you will recall that the transformations are y equals AF of kx minus d plus c. A is the vertical stretch, compression, and flip. K is the horizontal stretch and compression and flip. D is the horizontal translation, right and left. And C is the vertical translation, up and down. So if we replace f of x with x cubed, we would get y equals a times kx minus d cubed plus c, and in the quartic we get y equals a kx minus d to the 4 plus c, and that's just what we're going to be working with today. So we know that we can use those to describe transformations and then sketch it. In case you forget, the cubic function, parent function, is like this, where it's got sort of a parabola on that side and a parabola on this side. This is x and this is y. And it's got points like 1, 1, 2, 8, and so forth. So it's a bit steeper than x squared. And x to the 4 actually looks a lot like the parabola, but it's got sort of a square bottom. So if the parabola looks like this, where it's got this sort of round bottom there, then the quartic is going to look like this, where it's a little bit more square on the bottom, but then it goes up more steeply. So it's got more of a flat butt. And they touch at 1, 1 because they both have 1, 1. So x to the 4 is that blue one, and x squared is this red one. And it also goes through points like 216, which is 2 to the 4, and so forth, 381, and you get the idea. Okay, so we're going to be working with these two graphs, x cubed and x to the 4, and we're going to be transforming those like we would any regular graph. So before we do this, we want to make sure that we have the inside factored, and if it's not, then we have to do it. So in this case, we're going to get negative 8 times a half x plus 2. Don't forget, when you common factor, you're dividing the second term by the common factor, and so 1 divided by 1/2 is 2. Cubed minus 3, and if you expanded it, you could see that that was true. And actually, this is a little bit complicated, and we want to make it a little bit simpler. So we're going to take this cubed, and we're going to move it to the outside. So we're going to get negative 8 times a half cubed times x plus 2 cubed. And we're allowed to do this because that's part of the rules. Minus 3. You can see this becomes negative 8 times an eighth x plus 2 cubed minus 3. So we actually get negative 1 times x plus 2 cubed minus 3. And so we have less transformations to worry about. So if you can simplify it, you should. In fact, with the quartic and the cubic, we usually want to simplify it first, and when we look at how to create the equation, we're only going to choose either the vertical or the horizontal, and usually it's easier to do the vertical, so I'll usually choose the vertical to do instead of the horizontal. You'll see what I mean in a second. So anyways, I'm going to draw my parent function, because you always want to draw your parent function with the transformation. So we'll just draw 0, 0 is in there, 1, 1, 2, 8, and 3, 27, which is way up there, and then we get negative 1, negative 1, which is somewhere right there, 2, negative 2, negative 8, right here, and then it goes off into negative 27, so I can't get that far. So I'm going to connect the dots in a curvy and attractive manner, just try your best. And with our graphs, we want to try to keep them not stretched out, so we want to keep it a 1-to-1 ratio. So that's why I have 1s, even though I know that I'm not going to use that much to the left and to the right. And so the transformations here are, we've got a vertical flip, we've got to go left 2, and then we're going to go down 3. So we're going to do this one first, and then we'll do these two together. I'm going to do this in blue, and then I guess I'll do the last one in red or whatever. So blue first, I'm going to do a vertical flip, and you just have to take all the y values and you multiply them by -1. And we've been doing this quite a bit, so hopefully you're an expert at it, and we're just going to draw. And remember that when you have a graph, you want to make sure that you use up the whole grid, and you can't just, stop in the middle of nowhere so you don't have a floating graph. So if you want to draw a smaller grid, you can. And don't forget to label that. That's going to be y equals negative x cubed. And then we're going to move every point left 2 and down 3. So 1, 2, and down 3, 1, 2, 1, 2, 3 right there. And then left 2, down 3, 1, 2, 3. We don't have any other points there, so this one's going to move left 2 and down 3. Oh, actually I forgot this one, left 2 and down 3. Somewhere right there. Obviously you want to avoid having your numbers cover up everything. And left 2 and down 3. This is good because it also gives us our y-intercept, and we're going to see our x-intercept as well. And you can see that actually with this graph, I don't have a very crazy cubic graph. It's only got that parent function shape, and that is okay. In fact, that's what we're looking for when we're just doing transformations. We won't be able to use the transformations to find the crazy camel humps that we're used to, so don't worry about that part. We're just going to do our best to get the function as it is, and I'm just going to write in the function, so y equals negative x plus 2 cubed minus 3. And there you go. That's all you need to do. It's just regular transformations like we've always done. So sometimes you might get asked to determine the x-intercepts of a function, and we might use that to graph. In this case it doesn't ask us to, so we're just going to determine it. Remember that x-intercepts mean that y equals 0, so we're just set the whole thing to be 0, and then we're going to solve, so we'll move the 48 over, just like we would really usually solve anything, and divide by 3, so 16 equals x plus 6 to the 4. Now remember, if you have an even exponent, you do need to do plus minus, so this is going to be plus minus the 4th root of 16, which by the way is 2. So we're going to get plus minus 2 equals 6, or sorry, equals x plus 6, and so negative 6 plus minus 2 is equal to x. So we actually get 2 double roots in this question. We get x equals negative 6 plus 2, which is negative 4, or x equals negative 6 minus 2, which is negative 8. And that's it. Okay, so I just wanted to show this one. You can see I haven't even drawn a graph here because actually this is almost impossible for us to sketch because we're not in factored form and we are not in transformation form. So what's wrong with this question is that, I'm going to have a lot of difficulty with it. All you can see from it is the leading coefficient. You can see the y-intercept. You can see the degree is equal to 4. So other than that, we really can't get a lot. And so what we were doing in 3.2 with this was just saying, okay, I'm going to go through the 2, and then I've got some general shape where it's opening upwards, and then I know it's cubic. This has started to be not good enough now that it looks like an X. Now that we know a lot more using these two forms, so we won't be seeing a lot of these types of sketches anymore. Okay, so this is going to be the last example. And it just asks us to write the equations of the functions below. So you just have to look at them, and you know that the vertex, the vertex, is affected by the translations. And then, like I said, when we choose the stretch, we're actually going to choose either vertical or horizontal. I always choose vertical because I think that's easiest to see, but sometimes it is easier if they give you a specific point to see the horizontal. So just pick one stretch / compression. So if you look at this one, I know it's going to be x to the 4, and you can see actually it's got that very square bottom, like I said, and you can see that the vertex is right here at 1, 4. So I know this tells me what the D is and the C as well, because these are the horizontal translation and the vertical translation. And so the only thing I have to figure out is the stretch, and you can see that. I'm just going to look along the graph for where it touches, it goes through the corner, and you can see it's right here. And just like with the quadratic, because I go through 1, 1 usually, whatever it gets stretched out to, so this is 1 over and 3 up instead of 1 up, that's actually going to be the vertical stretch, and that's why I said I like to do the vertical stretch best. So because I'm going 3 up, that means that my A is going to be equal to 3. So, and that's it. And you should just check to see if it should be negative or positive. Obviously it's positive because we're opening upwards. So the equation is y equals 3 x minus 1, x minus d to the 4, because I'm using to the 4, quartic, plus 4. And that's it. Okay, so don't make it more complicated than it is. It really isn't a lot of work. Okay. And so sometimes you might get something like this where it's not really immediately apparent where to touch. So here we're going to go with the vertex again, which is right here. And I'm going to just label the point, -1, -5. And I might have to actually massage this a little bit, but I do know that I have my point here, which is -3, 7. So again, I'm just going to choose either the A or the K to find. I'm going to actually always find the A pretty much. So I know I have a cubic function, and I'm hoping to get a negative A since it's starting in infinity and going to negative infinity. And I know that I'm going to have it of the form, well, this is going to be D and this is going to be C, and I'm going to find A. So basically I'm using y equals A times x plus 1 cubed minus 5, and I'm going to plug this x and this y into the equation and then find A like that. So that's another way that you can do this type of question, and if it gives you y-intercept, then you just use, the number and 0. So I'm just going to plug it in, or I forgot what the number was, -3, 7, so 7 equals A times -3 plus 1 cubed minus 5, and we'll move the 5 over. 12 equals A, -3 plus 1 is 2 cubed, so that's 8. So A is going to be 12 over 8, or 3 over 2. And so we already have our answer, so we can write out the equation. Y equals 3 over 2, x plus 1 cubed minus 5. And that's it. Okay? So basically what we learned was that we can do transformations on the cubic and the quartic, and that we can find the equation of that as well by looking for A. Thanks for watching, and bring any questions you have to class.